At Apple in Fremont, California, people and machines work together to build the highest quality personal computers in the industry. This facility combines state-of-the-art equipment with a skilled workforce to achieve manufacturing excellence. First, certified suppliers deliver high-quality material to the Apple receiving dock. Then, logistics personnel remove material from its shipping containers, count it, and place it in a storage bin called a tote. This material receives a bar-coded serial number, which is entered into an MRP2 inventory system. Part number, vendor number, PO number, and quantity are all bar-coded on the shipping bill. Logistics personnel put enough material in each tote to adequately supply the assembly line. The raw material needed to build a Macintosh circuit board then moves toward the automated storage and retrieval system, known as the ASRS. This computer-controlled carousel system rotates to provide access to each tote. Totes move to the ASRS and are automatically inserted into the next available storage slot. The entire operation is monitored and controlled by Macintosh computers and trained personnel. When a request for material comes through, the ASRS selects the correct carousel and tote and delivers it to the pickup station. At this stage, the automatic guided vehicle, or AGV, picks up the requested material. Then the AGV moves to the delivery location, following the black and white tiles on the floor. At the beginning of the assembly line, an operator loads a printed circuit board into a screen printer machine. The bare circuit board aligns to the assembly fixture using a video camera, which verifies known points on the board with a stored pattern in the machine. Then, solder, in the form of paste, presses onto the board through a brass stencil. This solder will later hold the electrical components in place. This screen printing operation is similar to creating silkscreen designs on fabric. Pick and place machines automatically inspect electrical components before placing them on the circuit board. A rotating tool head then places the parts on the top side of the board, where the solder paste was deposited. This process is known as surface mount technology. A skilled operator monitors the equipment to keep the machines filled with components and to ensure proper operation. Because of the various sizes and assembly requirements of the components, several different machines are used. Then, in an infrared oven, the solder paste melts or flows and binds the components to the top side of the board. This process is known as infrared reflow. The circuit board now flips over so that small components can be attached to the bottom side. The tween stations on this pick-and-place machine temporarily glue tiny components to the flip side of the board One station glues, the other places. These components will be soldered to the board later in the assembly process. The circuit board is subjected to infrared reflow to harden the glue, and then it flips back to the top side. The operator enters a bar-coded serial number which is used for real-time data collection and tracking. A mechanical shuttle moves the circuit board across walkways so that people have access to all areas of the manufacturing process. The assembly line is designed in a U shape to conserve space, and that requires that the circuit board be turned 90 degrees to continue on its journey. Robots pick up components which are tedious to insert by hand. These parts are picked up from a specially designed feeder mechanism. Small components like these speaker connectors automatically present themselves to the robot arm for insertion. If a component does not fit in the first few tries, the robot will pick up a new one and retry the insertion. All parts that have wire pins or tabs that go through the circuit board are clinched from underneath to hold them in place. This eyelet setter or rivet press secures any large connectors which are located at the edge of the board and which need extra strength. Some large components have to be hand-placed. A computer user may plug additional circuit cards, such as memory or a communication modem, into these larger connectors. The circuit board now contains all of its components. An operator makes a final visual check to be sure that the board is ready for soldering and, again, enters the bar-coded serial number into the online quality information system. A wave solder machine does the final soldering. Here, the bottom of the board is first coated with solder flux. This substance prepares the surface so that the solder will adhere correctly. Molten solder at 470 degrees contacts the component leads and electrical circuit connections on the bottom of the board. Notice, the hot solder just touches the wire leads. The circuit board assembly is now complete. An operator trims any long component wires and visually inspects the board. Another operator now tests each circuit board by putting it on a set of metal pins built into a tester. The tester exercises circuits and tells her whether the board is defective or good. Boards which pass the electrical test move into specially designed carts and go by truck to a nearby building on site. Boards that fail stay behind for more tests. Using sophisticated diagnostic equipment, technicians isolate defective components and mark them with a red arrow. At another station, a skilled technician repairs or replaces the defective parts. The circuit board is then retested and sent on to the final stages of the assembly process, which we will see next. Meanwhile, a recreation area and fitness center are conveniently located on site. Whether on the shop floor or on the basketball court, teamwork is a key element to manufacturing excellence at Apple. Building 1, the original Mac factory facility, continues to be the center of production for the final assembly and shipment of Macintosh systems. Design for Manufacturability, or DFM, makes the assembly of a Macintosh computer simple and efficient. This operator easily installs the speaker assembly and the data cables for the disk drives. The disk drive mounting bracket, along with the floppy drive, inserts into the case. The hard drive snaps into place and the drive power and data cables are attached. Next, the operator installs the power supply for the computer, and the system is powered up to prepare for the first phase of testing. During this first phase, test cards are temporarily installed to allow software to exercise all areas of the system. An operator monitors the testing and verifies that the system is running correctly. The test cards are removed and the top of the case is snapped on. Operators audit a select number of completed machines to monitor the quality of the assembly process. And then, the machines move into a run-in tower, where software exercises them continuously for 24 hours. When the Macintosh systems leave the run-in tower, they return to the assembly line on an elevator. Now the computers go through their final system tests. Any dirt, dust, or fingerprints are carefully wiped away. Then, a process monitoring Macintosh reads and verifies test results stored on a diskette. The system software loads automatically into the completed machine's hard disk. Next, an operator verifies the video image, and the completed system receives a permanent serial number and is bagged for shipment. If a system fails anywhere in the process, a conveyor takes it to a rework area. Here, a technician replaces any defective components and retests the system. Once the computers have passed all of their tests, operators begin the packaging process. Accessories such as a mouse, power cord, diskettes, and instruction booklets are packaged along with the Macintosh. A completed system and accessory kit automatically insert into a shipping box. Tape applicators seal the top and bottom, and the boxes move along a conveyor. Then, they collect together on a cardboard sheet to form a shipping pallet. A completed pallet is wrapped in plastic. The plastic wrapper protects the boxes and provides strength for the pallet. A forklift moves the completed pallet into a waiting truck. When the truck is fully loaded, it leaves the manufacturing facility and drives directly to Apple distribution centers. Working together, people and machines have created a complete Macintosh computer in about 36 hours.